Hello, welcome to this video. My name is Tahir and today I will be discussing how we can design effective instructions using multimedia. So in this video I am using my reference book, a Cambridge Handbook of Multimedia Learning edited by Richard Mayer. So this is a reference book that the multimedia learning means we learn from words and pictures. The cognitive load theory is proposed by Dr. Sweller on the basis of how human mind learn new stuff. So he has adopted this theory on the basis of Atkinson's research that we receive information from our sensory system, and that is our sensory memory, which has unlimited capacity, but it can hold information for a very brief time. It filters out what necessary information we need to process into next step, that is our working memory. The working memory has a limited capacity and it can hold only 5 to 9 elements at a given time at one time, and it processes those informations and then it integrates information on the prior knowledge, and then this information will be related to if we have a prior knowledge, or we have to integrate, select and process actively into our long-term memory. So the cognitive load theory is based on that we have a limited working capacity. So the information when we are presenting in a learning environment, we need to know that our working memory is limited, and at the given time we can give information that the individual can process easily. So this working memory can be easily overloaded. So that's what is the basis of cognitive load theory. So cognitive load theory is the information that exceed from our individual's working capacity to process, and there are three types of cognitive loads. Number one is intrinsic cognitive load. Intrinsic cognitive load means that the complexity of the material, complexity of the material, it has a very needs more working memory, it needs more attention, and it can easily overload our cognitive capacity. The second type of cognitive load is extraneous cognitive load. Extraneous cognitive load means the way we present information to the learners. They can have a overload cognitive capacity of the learner if we throw too much information, unrelated information and complex PowerPoints or slides. So that can easily overload our cognition or cognitive capacity. The third type of cognitive load is germane cognitive load. So germane cognitive load means generative process, where the learners need to process, integrate and make mental schema and put into the long-term memory, and they can build new knowledge on the base. Now we will discuss what is cognitive theory of multimedia learning. The cognitive theory of multimedia learning is based on the cognitive load theory, because multimedia learning is learning from the words and pictures. So the cognitive theory of multimedia learning is based on three things. The one is Pavlov's dual channel theory. That means we use two different channels to process information presented to us. One is our visual sensory system, and second is our auditory sensory system. And these informations are separately processed in our mind. So we have a visual processing system in our mind that is separate from the auditory system, and we can take advantage of this to decrease the cognitive load in our individuals. We can expand our working memory if we can divide the information we want to present to the learners or to the audience by dividing some information presenting into auditory system, the other information presenting into visual system. Okay, and then this visual system and auditory system in working memory, they have a limited capacity, so we shouldn't overload these two capacities. It's just directly related to our cognitive theory of cognitive load theory. So the working memory will process these informations, and then it is active processing, the second principle of cognitive theory of multimedia learning, or principle where we are designing our multimedia learning instruction design, is that we have to actively process those information and integrate into our prior knowledge. So the prior knowledge is important in cognitive theory of multimedia learning. If we have a prior knowledge, it is easy to integrate the new information, and that can lessen our cognitive load, that can expand our working memory. So that's why there is a principle which is called pre-training in multimedia instructional design, where if we are presenting and now we will discuss three principles of cognitive theory of multimedia learning to design our instructions more effectively to reduce the cognitive load. So the first principle I will be discussing, that is related to decreasing the extraneous cognitive load. So the coherence principle, that means we should exclude all the unnecessary, unrelated information from our instruction design. Okay, and then the second principle is redundancy principle. That means if we are presenting information in narrative or in on-screen text and narration, or pictures all together, or sounds, so we have to use one channel for one information, another channel for another information. So if we are having a narration and then on text, so that can also overload our cognitive capacity. The third principle to reduce extraneous cognitive load is spatial contiguity principle. Spatial contiguity principle states that if we put pictures or diagrams or graphs and related words near to each other, it is easy to learn and it can lessen our extraneous cognitive load. Now let's see how we can apply these three principles in my next slide. So in this slide we have a heart picture. So this is a diagram, and we want to learn different part of the heart. We have left atrium, left ventricle, right atrium, right ventricle, aorta. So all those informations we need are in this picture. So this is a minimum cognitive load. Okay, so what principle are applied here? We do not have any unnecessary graph or picture or any sounds. So we have very much related information to this diagram. We do not have any on-screen text that can cause redundancy. Any on-screen unnecessary text or unnecessary graphs that can have a cognitive coherence principle. And then spatial contiguity, you can see we have all the words related to this diagram are very approximate or close to each other. So this is a good example of applying these three principles that we have discussed now. In next slide, it is an example where we see all three principles. Now this is a simplistic way to represent the blood circulation in the heart and in the body and the lungs. So this is unnecessary graph. it has nothing to do with this diagram. So that is a coherence principle, we can exclude this. Then we have on-screen text. So if I'm narrating this picture, if I'm describing this diagram, that blood from rest of the body that is deoxygenated enter into the right atrium, then to the right ventricle, then to the lungs where oxygen and carbon dioxide oxide exchange takes place, and then oxygenated blood enters into the left atrium, from left atrium to left ventricle, and from left ventricle it moves all over the body. So when I am describing, I am narrating this, then I do not need this on screen text that can cause redundancy, and that can cause our cognitive load, that can overload our cognitive capacity. So we can take this unnecessary image, we can take this on-screen text that is not required, that can cause redundancy, and then the spatial contiguity is already applied, that all the relevant words to this diagram are very approximately close to the relevant structure. And hope this will make sense when you are designing your instructions using multimedia. And now we will discuss another principle designing in our instructions or effective instruction design, that is refutation text. So refutation text means that when we have a misconception in science or in any content and any area of expertise, it is difficult to change because we have beliefs, we have prior knowledge that may be wrong, but we stick with that misconception. So it is not easy to change our concept. So conceptual change needs evidence. Okay, so this slide where we have a refutation text, that means we have a statement which is wrong, then there is a pause that says it is wrong, and then we give them an evidence. So this way, if we present misconceptions and we can correct, this is effective way to teach in science, especially in my field. So in this text, it may be no redundancy, but I just want to explain that it is misconception amongst many medical students that in physiology, that if you need more oxygen, you should breathe rapidly. Whereas more effective way to get more oxygen is to breathe deeply. The reason is that when you breathe rapidly, you not only increase your physiological space, you also increase the dead space. In each breath, you add 150 ml of dead space and 350 ml of physiological space where actually oxygen exchange takes place. Whereas if you breathe deeply, you can increase your physiological space and your dead space will remain constant, and then you can extract more oxygen. So when you give them an evidence, then that their conceptual change occurs. And I hope that this will make sense now. So in conclusion, we can use our cognitive load theory and cognitive theory of multimedia learning in our instruction design to foster learning in our learning environment. So using all these principles that I have not discussed in this video, you can check in my Weebly website, where we have how we can manage our extraneous load, how we can minimize or intrinsic cognitive load, and how we can manage our germane load. And I hope after this video, you will be designing your courses applying all these principles. And I will see you in next video. Thank you. Take care.